Yes, hello, my name's Will. I work here at Hootsuite, and I'm going to give a presentation today just introducing how we use Golang at Hootsuite and do sort of a close look at some microservices that we wrote that we use for anomaly detection. So hopefully, if you're a little bit newer to Golang, you can learn a little bit about some design patterns to build backend services using Kubernetes and Go and how they can work well together. Maybe if you have a bit more experience, you can just get a feel for what we're doing here at Hootsuite, and that might be nice as well. In terms of like anomaly detection, I don't think we're going to be presenting any like mind-blowing ideas, but just a simple way to look at how to keep track of data quality issues when you're working with large sets of data that are being updated kind of on the fly. So with that in mind, let's dive in. So here in Toronto, we're a team called Impact, which is an enterprise offering from Hootsuite that specializes in allowing clients to measure their ROI on social media. I wanted to say that just like my manager asked me to, so that is exactly what we do. So yeah, Impact is an enterprise offering at Hootsuite. We tend to have larger clients with a big social media presence and lots of different accounts, a lot of ad spend, and we try to enrich their data, present their data with a lot of added value. So what we tend to have in terms of our backend is these data processing pipelines that are written almost exclusively in Go that work to gather and then process large amounts of data multiple times a day to give near real-time insights into ROI and other kinds of value-added perspectives on social media and advertising in social media spaces. So Hootsuite as a whole has about 12% of their code written in Go, but that's growing by leaps and bounds. It's been a big organizational push to hire and encourage more Go development in the company. And we see that in like widespread adoption of like adoption of more microservice architecture. And of course, our team here in Toronto writes almost exclusively Go code, which is really nice. What else to say? So why do we use Golang? For a lot of the reasons that we already heard. It's a really easy to learn language. It's a relatively compact binary that has no runtime dependencies, so that's super useful, especially if you're hosting things in like a microservice architecture. And it's also like an easy to learn kind of lingua franca for distributed teams. So we're working with people in Romania, we're working with people in Vancouver, we're working sometimes with people in Italy, and it's nice that we all have this easy to learn kind of referent in a coding language that's pretty transparent and tends towards smaller, easier to read files. So that's nice. It's also, we talked about concurrency and the strongly typed language and the benefits that gives you. So that's the why. So Anomallama, I'm proud of that name. I fought for that name. So we used to have a QA person. That person left, and we started to say, well, we could hire a new QA person, but what are some simple tools we could use to do some pretty simple kind of, I call it like a smell test. So we have a lot of data moving through our pipes. There's a lot of reasons that our data can have inconsistencies with it. Some of those reasons could be bugs in our own code, right? But just as likely, perhaps more likely, is that our users aren't always as sophisticated as we are in terms of how they manage their social media presence from a technical perspective. So auth tokens can expire. People can there's all kinds of things that our users can do when they configure their Google Analytics profile. They can decide they're going to use a whole bunch of complicated rule sets that cause things to break. So for whatever reason, our data quality can sometimes be compromised. And so we need a way that says, like, regardless of output at the far end, like all the way downstream, how do we make sure that our data looks pretty good, right? Like, is it doing anything really weird is kind of the question that Anomallama tries to answer for us. So we wanted a flexible approach that allows us to share our like data like issues, anomalies that we might have detected with people that we don't necessarily trust to go into our databases or look at our logs. So we wanted something that kind of like looks for data quality issues, finds them, and then reports them in a way that provides enough information to act on it, but isn't oversharing anything from like a DevOps perspective that we don't want to share, right? So that was one of the things we were looking to do. And we also wanted to be able to have kind of a lot of flexibility. So when we talk about anomaly detection, the first question that you should ask is, well, what do we mean by an anomaly, right? Because statistically, that is a pretty slippery beast. So for us, we wanted to be able to define anomaly however we pleased, right? So maybe for a certain kind of social media metric like followers, an anomaly could be that metric drops to 0. People's followers typically don't go to 0 on their own accord. So that might be in a case of one way of defining an anomaly that makes sense. So we wanted to have a whole lot of custom ways of defining an anomaly rather than trying to create some sort of like machine learning pipeline that can intuit what an anomaly might be and respond to it. Well, that would be really neat, and I hope someone here builds that. We wanted to do something a little bit simpler and quicker, right? So we wanted to build something that provides a quick and easy way to understand what our data is doing and to catch some big issues before our clients do, so that we can be the guys that say, oh, by the way, you poorly configured your Google Analytics tools. We caught it, we fixed it, and our customers are happy, and then we're happy. So that's sort of the high-level kind of product vision of why we built Anomallama. When we look at it from a more technical perspective, it's a set of 3 interrelated microservices that speak to each other through a queue. We have a cron job that runs at regular intervals. That cron job gets a set of pre-configured tests from our database. It queues up those tests to move through our pipeline. That pipeline starts with an orchestrator. That job is to, as I say here, prepare and normalize the data. So we wanted to have whatever our data source might be. So we have multiple different data stores like Firebase or Mongo. We wanted to be able to have the ability to like normalize data from across a whole bunch of different data sources in one place and then apply some predefined tests to that. So I'm going to show you guys what our queue worker architecture looks like, kind of from a bigger picture, the design patterns that we're using to give you a sense of how you can use Go to do these kind of problems, to solve these kind of problems. So let's take a look. Maybe before I dive right into the details, just to give you a higher level overview, the orchestrator prepares and normalizes the data, the analyzer runs the tests, and the reporter then reports to wherever we want it to report to. And we have a couple of different integrations at the moment. So I hope people can read this, but this is some code for our consumer. So if you think about these queue workers, there are these microservices that are sitting, listening to a queue, and what they do is they have a consume function that basically takes a payload from our queue and creates a new instance of an orchestration. So if there's an error, it throws an error, and then it runs the payload runs that payload that it just received, right? So we have here, we load our environment variables from Kubernetes. We connect to to S3. We connect to whatever Mongo driver or whatever database drivers that we would need in that case. And then we create this consumer that's got all of the database connections and connections to third-party services that we need, that's sitting there waiting for queue messages to come through. It's got its consume function waiting. And here we here we create the consumer that knows how to call this consume function. And here we have the processor. So that's sitting, listening to a specific queue name that's predefined for each service, has its own queue name. And we keep a health check going in the background. So to kind of zoom out a little bit, we have these consumers, these structs that have a consume method. They listen on a queue and they get a new message. They call their consume function, which we'll look at next. They run with a health check going in the background that makes sure that the queue is still working and that the databases are all alive and all of that. So that's how our consumers work. Very simple, very standardized. That pattern that I maybe went through a little bit quickly is used across most of our microservices that are on a pipeline. But the logic that the consumer calls, and once after that consume method gets called, now that's what's going to vary between all the different services. So consumers might have different drivers and so on, but the actual work is done in the kind of libraries that are underneath that consume method, right? So here we have a worker. It has this orchestrator that we saw in the previous slide. So we build that orchestrator here. We have initialized it with all of the drivers that we need, all the connections to Mongo and S3. And we initialize it like that. And then when we get a new message in our consume method here, we create a new orchestration. So the idea is we have these kind of permanent connections to our databases and what have you. And then while we process data, we spin up instances of this orchestration type, which has the more specific payload that we're interested in processing, right? So that's like company information, their platform ID. So for Facebook, their page name. We also have information about the tests that we want to run. So all the details are in that payload. And then we call this run method here. And basically, we have for whatever data source that we want to be able to orchestrate data for, we have different methods. So maybe we grab from Mongo or we grab from Firebase. And of course, it's easy to build this out more to support other data sources should we need to. And then basically, once we've gotten the data from our data source, which I'll spare you the details of, we upload it to S3, and then we send the message to the next step in our platform, which is the analyzer. So hopefully that's like a very fast, high-level overview of sort of this queue worker architecture that we use. If we have any questions, does anyone have any questions now, actually? That might be a good opportunity. Yeah. No, we use Kestrel, which is actually an old-fashioned queue, I guess, by today's standards. It's basically just a wrap around a Memcache server, so it supports pretty basic, like kind of round-robin style queue reading. Yeah?
Sorry. How long did it take you guys to come up with the beginning to end using Go?
That's a good question. I think the first iteration was pretty quick. I think we had built it out. I worked pretty closely with my coworker Percallan over there. Shout out to Percallan. I think we did it in about a month or something like that, the first round. But there was a lot of like tweaking. So one of the big questions that we had here is like, kind of gets to this like epistemological issue of like what is an anomaly and how are we going to define that in a way that makes sense for our data? Because a lot of, and this actually is a good segue into how the analyzer works, because the hardest part of this was actually configuring our tests, the kind of statistical tests we wanted to run against our data to give us more signal than noise, right? So let's say we define an anomaly as something that's 3 standard deviations from an average, and that might hold true for normally distributed data most of the time. But if your data is not normally distributed, you can expect to get a whole lot of false positives and a whole lot of false negatives, a whole lot of noise. So the real challenge, the real hard part, and that took months of tweaking and talking to our customer service support CSMs, I don't know what the M stands for, customer support manager, talking to those people about what their customers wanted and trying to understand what gave us the most useful and reliable output. So that was really interesting for me. I got to study a little bit of statistics and like freshen up a bit on some ways to look at data that is not normally distributed, and there's a lot of interesting ways to do that. So the tests that we support, I'll get back to this. This is the output in Slack that we have which is one of our integrations in the reporter, but I'll come back to this in a second. So the tests that we support, one of them is called the Doom test, which Percallan named. I like that name. We basically define a time series as being anomalous if there are more than n consecutive 0 values. So the example would be like your follower count drops to 0. That doesn't make sense. That's an anomaly. Report that. And we learned to do consecutive 0 values because there are intermittent API issues that are just normal and to be expected, and they kind of get ironed out over the course of running our data processing pipelines multiple times a day. So we needed to have a little bit of, again, it's kind of getting that signal from the noise, right? So that was kind of a learning we had. Magnitude test is just a simple like percentage difference from an average, which is not very memory intensive and is pretty useful for data that's pretty consistent. So like if we have a queue message payload, so Firebase we use for a lot of our queue monitoring. If we have like 100 queue messages that go into our collector, we should have 100 messages that go into our processor. And if there's an 80% decline in our messages, that's weird. And so for like more functional kind of applications, these kind of simple tests are useful and they don't take a lot of memory. And then the old warhorse of like anomaly detection, of course, is standard deviation, which is really great if your data is normally distributed. And one of the things that I learned reading up on this project is this idea of like the 3 sigma test, which is the idea that if something's more than 3 standard deviations from an average, that's really weird. That's probably an anomaly. You should probably do something about it. And that's useful for things like network traffic and things that tend to fall along a bell curve if you do it, if you get it with enough data. But social media usage isn't like that. It's just not normally distributed. So there's actually a lot of cool tests that are good for not very normally distributed data, like the Kologrov-Smirnov test, which is used for, I don't actually know how it works under the hood, but it's considered to be like a pretty good statistical test for data that's not normally distributed. We didn't implement it yet, but the way that we built our pipeline, because our tests are all configured in Mongo in advance, and we're pretty flexible with how we can, what kind of tests we can run, it's really easy to build out more logic as we go should the need arise. So it turns out that these 3 tests are covering most of our bases most of the time, and they're catching most of the kinds of errors that we want to catch often enough that we haven't seen a need, or my manager hasn't seen a need to like make tickets to build more of this out. But I think in the future, we definitely want to do that. And so let's just go back to the output aspect of this. So remember, in our architecture diagram, we have our cron job that runs several times a day and kicks off a job. It moves on to an orchestrator, which prepares and normalizes the data using that consumer worker architecture. The analyzer runs a test using the same kind of architecture, but differently configured with different logic in the worker. And then the reporter uses the same kind of consumer with some different drivers hooked into it and different worker logic. And what the reporter does is it takes a chart based on the time series data that we flagged as anomalous and can send that chart, which looks like this, to Slack, which contains enough information for our customer service people to quickly pull up this connection and take a look and see if their auth's been invalidated, see if there's any obvious issues that they can help address, or to simply, our customer support workers have the ability to rerun our data processing pipeline on the fly. So they're able to quickly do backfills and things like that if we catch gaps in our client's data, which is really nice and makes us seem really on it. Well, because we are really on it, we don't just seem on it. So yeah, here you can see our LinkedIn followers are declining in a way that doesn't really make sense. And another thing that we've learned a lot about is kind of how to work with our customer support people to give them information that's really useful. So this is actually an older version of the Slack output. We have a lot more data there, and we're looking into using some of the Slack API features like threading conversations so that we have by company more filtering. And we also support an integration with Grafana, which actually hasn't worked as well as I thought it would. Like, we were pretty stoked about it at first because Grafana has all these like beautiful dashboards and stuff, but it's actually not really keyed up for this kind of intermittent data. Like, Grafana wants like regular time series, like the number of bytes per second for whatever. It doesn't really like every day, maybe for this particular company, this is a weird data set, right? So Grafana wasn't a great tool, actually, at the end of the day. I think we could probably learn to use it better to find ways to make that data look a little bit cleaner. But it's sort of like, is it worth the effort? And also, our customer support people didn't really like learning to query and filter things in Grafana, so it turned out to be kind of bunk. But we've thought a lot about oops, that's for later. We've thought a lot about sort of next steps. One of the things that I would really love to be able to do is to give the customer service people in their Slack channel the ability to flag things that are false, that are true positives. So like if we get an anomaly in Slack, I want someone to be able to click a button and that information comes back to us. And then what do we have? We have like a label we can use in like a machine learning pipeline. We suddenly have a lot more richer information about the data. So you could think of this as actually being an interesting first step towards having really useful information for a machine learning pipeline, which is kind of exciting to me. You could also have like a Slack bot that could use the output of the anomaly detection tool to run in Slack a lot of the simple kind of backfill jobs for data processing that can, on the fly, fix data quality issues. So it actually, it's a simple tool. The actual Go code, it's maybe 300 lines per each one of those services, and it's delivered a lot of value, I think, already. We've caught a lot of anomalies. So I'm not sure how I'm doing for time, but I think I'm going to kind of move into the sort of last part of the talk, which is the exciting announcement that I think we're hiring. I know we're hiring a lot more developers in Toronto. They may not be writing exclusively Go code, but they could be writing exclusively Go code, depending on which position they apply for. So yeah, that's exciting. And also just super stoked as a developer here to like kind of join this community of folks doing Go code in Toronto. And yeah, welcome. And thanks for coming. So any questions for me? Yeah.
sort of like time series database or monitoring tools that can achieve, I mean, might not be able to customize as much. But
oh, yeah.
results. Like, it might be much easier effort to just rely on them than writing a custom.
There's some really great third-party libraries that implement a lot of the statistical tests that we did by hand, but I liked writing those tests by hand, so I didn't mind that part. There's also like some really powerful time series databases that can do on-the-fly anomaly detection and aggregate in crazy ways. Like, I'm trying to remember the name of, one of them we were looking at was what's that? InfluxDB. We looked at using InfluxDB, which is like super, super cool. If you haven't looked at it, it does a lot of what we're doing for free, so you probably want to use that. But sometimes it's nice to do it yourself because you get all the customizations that we did, like the Slack stuff, the tests that we like, and our use case for like social media metrics and the kind of data that we get, we really like to be able to tweak it in ways that don't make any sense to anyone who's writing those kind of packages. So there's good reasons to do it yourself, and Go makes it so easy. Like it wasn't like we did it in like a month, the core logic was done in a month. It wasn't some big architectural feat, it was, the patterns were familiar and the code wasn't that mind-boggling in and of itself. So. Yeah, I think that was the biggest thing. So, question back here?
You said at the beginning that you were concerned about, from a DevOps perspective, of the unintentional release of data or the release of too much data. What department do you belong to, or do you embed DevOps into developer groups, or how does it work here?
Yeah, that's a great question. So we don't do most of our DevOps. We have a DevOps team in Bucharest who handles a lot of the security and Kubernetes infrastructure that is the backbone of our data processing pipelines and microservice architecture. So maybe that is speaking to your question, or?
So you, like the two of you that produced this are from a core developer team?
Yes.
Or from an operations team?
We're just developers, and we were responding to a need to have a little bit more ability to predict and respond to data quality incidents in our own data process that are a result of our own data processing pipelines. So that's how it came up from a product perspective. But we were working closely with the customer support customer support managers in the design of the product. They were our customers, in a sense, for the product. So question over here?
Yeah, as a follow-up for the question with the gentleman over there. You mentioned yourself InfluxDB, which is probably the best time series database out there.
Yeah.
They have been working, I believe they just released it in version 2. The original InfluxQL was kind of clunky.
Yeah, I used it.
However, they released Flux, which is a fully functional language that you can use to do your query. So
Cool.
you can still use that facility, and I mean, you can go wild with you can still integrate it with Slack, either through Grafana or through their other component, it's called capacitor.
Capacitor, yeah.
Which is not very used often, but you can still go crazy with your queries and write them yourself, and still use some, proven technology as your time series. And I believe most of your data here is time series based.
Yeah,
it looks like.
Yeah, it is, yeah. Yeah, we actually did a lot of benchmarking with InfluxDB versus Mongo, where we do our aggregations now. We're not really aggregating in any of this workflow much, not in a big way. And InfluxDB blew us away, like so powerful. But it comes with some like cost benefit stuff. But yeah, I'm really a big fan, and I was trying to get us to adopt that, and it didn't happen, and that's okay. So yeah, that's cool. Yeah, question back here?
So just another kind of open source related question. I'm curious if there's any kind of workflow type engine you might suggest after, because I know that like a lot of this stuff exists in Python.
Yeah.
Luigi, there's a bunch of these different things that make it easy to write kind of pipelines and workflows like this. But
Oh, yeah.
I'm not aware of it.
There's a Argo project is really, really cool. It's like, I don't know if you guys know Netflix's Conductor, which is like a microservice orchestration tool, but I think it's written in like C# or something, and it doesn't have, and it's opinionated about what kind of databases you plug into it. So we looked at that, and that wasn't great for a lot of these kind of like orchestrations of microservices. So like linear queues are easy. If you have this process talking to that process, that's fine. But like parallelism and concurrency can be a lot harder patterns. So having things like Argo, which is open sourced container native workflow engine written in Go, is really cool. And it comes with this awesome dashboard where you have like that diagram I showed you guys. I made that in with Google Slides. But imagine if that was like the actual workflow was like visualized in a dashboard for you that you get for free by just using this Argo thing, which is basically it's like a Kubernetes type that's a workflow spec where it looks like the YAML. You say oh, this is the first step of my process, and when these two things complete, do the next third thing, and then recurse on the outputs of that this many times. It's nuts. So I check that out for these kind of problems. Yeah.
So on a similar line, how much did you run into any problems with generally chaining your events like this and having troubles with did you have to put in a lot of effort to retry and stuff or random network problems, that kind of thing?
Yeah, that could be a real headache.
Things about that.
Yes. Yeah, no, we do every day. Yeah, really, truly, that's a hard problem. This less, but when you have 8, 9, I think we have one of our pipelines is 13 microservices, which was too many. It gets really hard to know if this job starts here and we have to make sure it gets all the way to the end. How do you know? You don't want to have a global state that's watching all of these services. They should really be independent. But yeah, those are some hard problems. I think we run jobs often, so if there's problems, we just hope that over the time they kind of even out. I know Anthony, wherever he is, has showed me some design patterns that can help account for problems like that, but it's certainly something that we run into. And it's kind of this second order of problems that you get with architectures like this, where you have the programming problem of how do I write efficient, clean, good code that does this thing well? And then you have this sort of second order problem of how do I write 3 things that are talking to each other, and all the kind of sort of meta problems that emerge. It's probably a better word for it, that emerge from the interrelationship of the 3 things. And those are really fun problems to solve. I love that kind of stuff. But yeah. Question here?
So I guess 2 parts. For workflow automation that's driven by containers, you should also check out Concourse, just a shameless plug because my company works on Concourse.
Cool.
Yeah.
Totally.
But the second question I had is it occurred to me when I was listening to you talk about data aggregation and just collecting raw events about what looks weird.
Yeah.
As someone who uses social media, that feels to me like really rich data to detect abuse on social media platforms. I'm wondering if you've had any conversations around leveraging the data for that. Yeah,
that's a really, really, really good question. Yeah, looking at patterns for bots, or yeah, you can understand an anomaly as a data quality issue, but there's another way of thinking of an anomaly. I hadn't actually thought of that. That's really interesting. Yeah, cool. I'm gonna have to think about that. But yeah, totally. That's interesting. Question here?
I think you touched on it a couple of times when you were answering, but so you did mention some things I guess you consider you may change if you were to implement this again.
Yeah.
But coming down to what we're doing, is there anything in Go that particularly stood out that you think was great working in it for this sort of problem?
Yeah, well, one of the things that I'm really excited about lately is Anthony's new to our team, and he's been showing us a lot of concurrency patterns, like using semaphore to have the consumer take 5 queues at once and spin up Go threads, so you can have really, you can jack this thing up, really charge it up with a lot of concurrency patterns that I didn't even touch on. So that's, as someone relatively new to Go, learning how to leverage that as many times and as many places as you can safely is really exciting. So I think we're just touching the surface. But yeah, this consumer worker pattern is cool because you can use concurrency patterns to have multiple workers on a single pod, threaded, doing the same, doing what you want them to be doing simultaneously. So you can really amp it up. And that's a pattern that we're still kind of integrating into our microservice architecture. So yeah. Cool. Any other questions or?
Let's give Rob a
Thanks.
applause.